Hi friends, here in this video we learn about the backward interpolation formula, in which condition this formula is used and how to use this formula for finding a given unknown approximate value for a given x value. Here we know that this formula is used to find out the approximate polynomial. Here we know y is equals to y of x. This is the unknown value. Here for finding the y of x by using backward interpolation formula or Newton's backward interpolation formula. Here y of x is the value of x. Already we known the value of x is placed at the end of the tabular values. That means the given here the values of the x value is always end of the tabular values. In this condition only backward interpolation formula is used. Here the end of the tabular values means the already we know for a given problem the values of x and y are given. The values of x are x0, x1, x2, x3 and so on. The values of y are y0, y1, y2, y3, etc. The value of x is at the end of the tabular values. Here for example xn is the end of the tabular value yn. Here the value of x is, suppose assume xn, so here xn value is the ending of the tabular values. So in that condition we use backward interpolation formula. Here the starting of the value x0, that means the value of y of x. Here the x value is the x0, that means the x0 is the starting value of the given values. So in that condition we use forward interpolation formula. So in this condition we use backward interpolation formula. Here we know that the formula for finding finding approximate polynomial, that is formula for finding y of x. This is the unknown polynomial. The problem for finding y of x, first we draw the backward difference table. First we draw the backward difference table. Here the formula for finding backward interpolation polynomial by using backward interpolation for finding y of x is that means xn is yn plus del y p into del yn plus p into p plus 1 by 2 factorial del square yn plus p into p plus 1 into p plus 2 into by 3 factorial del cube yn plus p into p plus 1 into p plus 2 into p plus 3 by 4 factorial into del power of 4 yn. This is the formula for finding a polynomial by using backward difference formula. Before that we can draw the backward difference table. The backward difference table is also same as forward difference table. but the indications are different. Here the values of the given values are x and y. Here the values of x are x0, x1, x2, x3, x4 and so on up to xn value. The values of y are y0, y1, y2, y3, y4 and so on yn. These are the values of x and y. So similarly can find out the del y, place of delta y. Here in this backward difference table can place del y. Here del y is the first difference of y1 minus y0 gives the del y1 value, and y2 minus y1 gives the value is del y2, and y3 minus y2 gives the value del y3, and y4 minus y3 gives the value del y4 and so on yn minus and so on yn minus 1. Yet the yn minus gives the value of del yn. Here this is the final del yn value. Here similarly we can find out the value of del square y. Del square y, here this is also the difference of del y2 minus del y1 gives the value is del square y2. Here similarly the value of the difference between del y3 minus del y2 gives the value del square y3. Similarly del y4 minus del y3 gives the value del square y4. Similarly finally the value of difference between del yn minus del yn minus 1 gives the value of del square yn. Similarly we can find out the del cube y value. Here del cube y value also the same, del square y3 minus del square y2 gives the value of del cube y3. Here similarly del square y4 minus del square y3 gives the value of del cube y4. Here this is the same. Finally the value of difference of del square yn minus del square yn minus 1 gives the value of del cube yn. Here del power of y also the same. We know up to the single value we can find out the values of del cube y, del power of 4y, del power of 5. These values depend upon the x and y values. How much values are given, depending upon that values, the how much of place we can find out the values. Here we know the formula for finding finding y of x by using backward difference formula. Already we know yn plus p delta yn plus p into p plus 1 by 2 factorial del square yn plus p into p plus 1 into p plus 2 by 3 factorial into del cube yn plus p into p plus 1 into p plus 2 into p plus 3 by 4 factor into del power 4 by 1 and so on. Depending upon the tabular values, the formula we can written. Here substitute the values of these values of in backward difference formula, then we can find out the value of y of xn. That means xn is the ending of the given tabular values. Here xn is the given ending of the tabular values. In that value we can find out the approximate polynomial for a given value. Here substitute the values of yn already be known, that means yn is the for a given y values, the ending of the y value gives the value yn, and p already be known, but for finding p value, here p is the given xn value minus the value. Here xn, that means we can consider it as x. Here the difference between x minus xn, here the xn is the ending of the tabular values, x minus xn by h. Here x is the given value, here xn is the ending of the value of x values, ending value of given x values, that means xn. Here h already known, this is the difference of given x values. These substitute the values of p and del yn. Here del yn means here the ending of the, for finding by using backward difference table, here del yn means here the ending value gives the value of del yn. Del square yn means del square yn gives the value in given backward difference table, gives the ending of the ending values gives the del cube yn and del power of 4 yn. Here the ending values of the given tabular values, gives the values of del square yn and del cube yn. Substitute the all values in a given formula, and finally we get the unknown polynomial, that is y of x. In this manner we can find out the approximate polynomial for a given value. Thank you friends.